Hello, good afternoon. Hope you all are doing great. If you haven't had lunch yet, I'm hungry too, so I'll probably grab something after this. So today we're going to talk a little bit about how observability works for microservices. And the point of the discussion that we're going to have today is that when we're doing microservices and organizations are building out these large distributed environments, things tend to start moving really fast, and things might break, and we may not know if they break if we don't have good monitoring in place and we have the tools to look into our environments and understand them. So, who am I? I work for Instana. I work in developer relations. I do education and awareness around SRE and DevOps type topics. I have a product focus on SRE. I work with our product team to help them understand how our customers use our software. And I also do content development, so things like webinars, blog posts, and workshops, and deliver those as well. I'm also a startup co-owner in Nashville, Tennessee of Single Music. And if you did happen to check my previous talk, I talked a little bit about the problems we solved there, but we're not going to talk about Single Music in this talk. I've been using Docker for about 7 years now, in production for 6. I've also heavily involved with my local community, DevOps Days Nashville, Docker Meetup, Golang Meetup, just a lot of community type work. So what are some of the things we're going to talk about? I'm going to talk a little bit about my view on observability, what that means to me, how distributed tracing plays a role in it, and then we're going to do a live demo, and we will pray to the demo gods that it works out. So what is observability? And we can trace this term back to a 1961 paper on control theory. And Richard Coleman, he theorized that a system is observable if we can determine the behavior of it based solely on its inputs and outputs. Now, this may seem a little nebulous. It is. But I think the point he was trying to come across with here is that if you can understand your system, then it is observable. And what you need to understand your system is an aggregation or a collection of its inputs and outputs. And that includes more than just, is my page returning a 200 OK? What were all of the actions that had to happen underneath that request to return that 200 OK is more along the lines of what modern day observability is to me. And the goal should be out of observability is that we're able to identify patterns or problems. We can assign significance. Doesn't matter if this pattern is reoccurring or this problem is happening. It should help us understand it. It should give us reasoning behind it, like why is this problem happening? And then it should also guide our action. How do we fix it? And when we apply the fix, did it actually work? And why do we need observability? Again, because our organizations have started adopting microservices, distributed systems, building out highly replicated application services, we see a skyrocketing in the rate of change. This isn't necessarily a bad thing. We want the ability to rapidly change, and we want the ability to quickly deliver value to our customers, but that comes at a cost. That increases the complexity of the system. And we have a choice. We can either adapt to it or we can collapse underneath the weight of this new paradigm. And in 2010, Google decided to adapt. And they did so by introducing a project called Dapper. And that was the distributed tracing as we know it today, first implementation. And the problem that Google had was that they had hundreds of teams, thousands of engineers, and dozens of programming languages all talking to each other, but they had no way to really understand the performance of those systems communicating with one another. So they built this system, and distributed tracing is simply injecting headers into every HTTP request, gRPC request, message queue. Anything that sends a transaction over the wire has a header attached to it that allows the monitoring system to create a record of that transaction and you correlate it to that request. What this means is that we can create a Gantt chart or a visualization of all of the transactions that happen within the context of a single request and gather information around the timing of them, as well as did it succeed, did it fail? If there was a failure, what was the error? Was there a stack trace that we could collect? What was the database query that failed? And there's all these different questions that we can ask of our system to send back along with that transaction record. And with that, we are given the ability with current technology, with a single agent type approach, where if an agent is running on a host and it's collecting information on the host about the containers, about the processes that are running in it, it's collecting the log information from those applications, it's collecting the metrics around the host, the container, the language, and the runtime, as well as collecting traces from the applications that are running in that host, then we can connect all of that data together and create what we call an aggregated request scoped event. And ultimately that means that anytime a distributed transaction occurs or a trace occurs, we can assign all of these different values and information to it that helps us troubleshoot when problems actually happen. And we get from all of this data, we get a lot of telemetry, and it's perfect for aggregation, for defining SLIs and SLOs. We can do machine learning around it, we can do performance analysis and debugging with it. Or rather, we get a huge data lake that we drown in. So that's where Instana steps in, because we collect all of that data and we create context around it. We create interactive dashboards and we help you understand what that data means. And the reason we do that is because we need our machines to reconstruct that data so that we can make decisions and how to react. Again, it's those 4 points I made on observability. So the demo I'm about to go through is based on Spring Pet Clinic microservice demo. This is open source. I built it on Kubernetes. It's a REST-based service. I've also added some Kafka components to it as well. And originally it was a monolith. I refactored, the community refactored it to microservices. And I removed dependencies that didn't really work well with Kubernetes. I also added some services, added a load testing script, and I also integrated it with GitLab and Kubernetes. The URL here, you're more than welcome to check it out. It's open source. You can set it up yourself. There's an entire workshop around it. So the Spring Pet Clinic has a problem, and let's go through and figure out what that issue, what the problem is. So before we get started on troubleshooting, let's kind of go through what the Spring Pet Clinic is, what problems it's solving. All right, so wait, that took a little while to load. Like, I'm not sure why that took so long. It probably doesn't need to take that long. Well, okay, I see why it took so long. It's because there's a ton of data here. So, yes. Okay. Thank you. All right, so this is the Spring Pet Clinic. We have a list of veterinarians. We have a list of owners that seems to be taking a while to load. And we can also register new owners. We can add some user. And that gets put into a database. And within this, we can also do things like we can add a new pet. We can add a visit. We can say, hey, this pet had a tetanus shot or whatever. It's just a pretty simple demo application. But again, there's some performance issues with it. If we go to load the owners, it's taking a while to load. So let's kind of troubleshoot this from the aspect of an observability tool. So what you're looking at here is a aggregated dashboard of all of the transactions that are occurring in this service. So the first item that you're looking at here is the number of transactions that are occurring within this service, the error rate of that service, as well as the mean latency. We can see something over here that looks a little anomalous. The 99th percentile is showing that there is a constant growth of latency. And if we zoom back out, we can see that there's a particular endpoint on our service that shows us how slow it is in comparison to the rest. So this particular endpoint, get owners, which corresponds with probably this page, is a lot slower than the others. So as we can see here, we have a list of every single transaction that occurred and its latency. If I click into it, I can see the distributed transaction graph. This is, again, that graph of activity that happened when somebody said, hey, I want a list of all the owners. And I can see here that these database queries are taking a long time to be fulfilled. So if I click on it, I can see that where the connection is, but I can also see how slow it is. So maybe there's some optimization or some changes we can make. Let's take a look at this page. All right, so, I mean, what would be something that we could do to fix this real quick? Yes? Pagination, yeah. That's pretty much the easiest fix that we can go with in this case. And I've actually already written the code. It's already built and ready to deploy, so that's what I'm going to do. And while it's deploying, I'll kind of explain how Instana goes and collects all this information from our applications. So I'm going to deploy the paginate owners branch. And again, while that's deploying, let's talk a little bit about how Instana collects all of this information. So as I change this to the live view, what you're seeing here is a dependency graph that shows us all of the individual services in our application. And I define this application by telling Instana that anything within this Kubernetes namespace, SPC, is essentially an application. And every one of these services and all of its instances, so for instance, if I go into customer service, I can see in the infrastructure tab that the underlying infrastructure for it. So I can see and jump to the Kubernetes service in my cluster. And I can also dive into that particular container as well. So it's running 2 instances, and I can get information around the container metrics along with the runtime metrics on the JVM and the Spring Boot metrics, but also the host metrics. So again, this goes back to that Venn diagram I showed you earlier where we bring together all of these different aspects of monitoring into one place to make it very easy for you to dig down and figure out where your application services are actually running in your data center and in your orchestration layer. So at this point, we should have some deployments going on. We can see here, actually Instana just discovered that deployment, and we can see there's some rise in activity. So in a few moments, we should see the result of this deployment and if it improved the latencies. But one of the things I want to talk about while we wait a few moments for this to deploy is that how Instana collects this data. Essentially, we've deployed the Instana agent through a Helm chart. It's a daemon set, which means that in Kubernetes, each host is going to get a single agent put on the host. And once that agent is running, it will discover automatically all the processes that are running inside of that host. And it will discover things like there's containers, there's processes. I know this process, it's a JVM, so I'm going to byte load the instrumentation that the JVM needs to export the traces and metrics. So what that means is that in a matter of 2 to 5 minutes, you can have all of the distributed traces and metrics being exported from your applications without having to restart your application, without having to change code, without having to do a new build. Our agent does it for you. And if you want to learn more about how that works, you can come talk to me afterwards or at my booth right over there at 511. So now that we've had a few moments for this to kind of settle down, we should be able to see that there are in fact some deployments running. Let's take a look over here at our application and see if the performance is improving at all on that endpoint. So if we get owners, we can see that there are some improving transactions. There's multiple instances, so it's still more than likely working on settling down from the deploying of all my services. But we can see here that near the tail end of the graph, where we had 800 milliseconds P99s over on the right-hand side, we're now down to 3319. So it looks like our problem was fixed. We can confirm that by going back here, refreshing the page, and seeing that yeah, there's no more 500 entries being pushed through. So with that, we'll wrap up. In summary, microservice application development isn't necessarily easy. There's even organizations that have gone so far as to just completely revert from microservices and go back to a monolith. I would argue it's because they didn't have the tools they needed to understand what their environments were doing, so it made more sense for them to switch back. Observability tools such as Instana, they're built to help you understand how your systems are performing without creating additional toil for your team. You shouldn't have to go through and spend a ton of time instrumenting your services and building dashboards, building alerts. Your tools should do that for you. And ultimately, share your successes and the lessons that you've learned implementing these tools in your environment. And feel free to come by afterwards and talk.